Welcome to the FEMAP model meshing demonstration. In this demonstration we'll see mesh size adjustments applied to the model prior to meshing, the meshing of the model and a review of mesh quality, and some further mesh improvements after meshing using FEMAP's meshing toolbox. FEMAP offers a lot of control of the mesh sizing prior to actually meshing the model. We'll review some of the methods available after first ensuring that the mesh sizing display is set, which displays node symbols along curves and the edges of surfaces. An element count can also be switched on, which will come in useful later on when we look at interactively updating the mesh with the meshing toolbox. There is a default mesh size set which can be changed, and the mesh sizes can be set individually for all geometry entities as well. Now we'll zoom up on the part of the model that contains the washer split surfaces around the three smaller holes. Here we wish to set a very specific mesh detail to ensure that regular well-shaped elements are created around each of these holes to capture model behavior to a greater accuracy. Note the use of the highlighter to visually verify the curve selection. With FEMAP you have full control over meshing and element sizing, and you can define very detailed meshing requirements by setting the mesh sizing on geometry curves and surface edges. This part of the demonstration is showing some of the ways of defining mesh sizing before the mesh is created, but it's also possible to interactively change the mesh after meshing using FEMAP's meshing toolbox, which we'll see shortly. With the mesh sizing settings completed, we'll now mesh all of the surfaces of the model using plot-only elements, as there are no element or material properties defined. Now with meshing completed, we'll take a look at some of the capabilities in the meshing toolbox, starting with the element quality display. In the Mesh Quality tool, there's a complete list of quality criteria that can be displayed, and a combination of criteria can be defined. It's also possible to set the maximum allowable value for each criterion. Now let's zoom up on a couple of areas of the model and look at the mesh. First the front, where we previously specified mesh sizing, and the side flange, where pad split curves were defined. Now we'll zoom up on the left side of the model and look at some of the other meshing toolbox tools. Features such as holes can either be suppressed or permanently removed, and this action can be done interactively and the mesh automatically updated. Now we'll reorientate the model to get a better look at the mesh on one of the corner surfaces where there are some issues. First of all, the short edges are made up of multiple curves, which can be addressed with the combined Composite Curves tool. Secondly, the edge meshes of the longer edges don't match, which can be addressed with the Mesh Sizing tool. All of these tools can be used interactively with the mesh and quality criteria plot updating accordingly. So with these modifications, a better mesh is placed on the corner surface. Finally, we'll zoom up on the corner of one of the surfaces to address the last problem, one single remaining element that fails the quality criterion. Here we can use the Mesh Locate tool and drag one of the corner nodes to manually change the element topology. Note that the node can be set to move only as the underlying geometry allows, keeping it in the plane or along the edges if applicable. So we simply drag the corner node until the element changes color to indicate that it now passes the quality check. And that's it. Zooming out, we can now review the entire model and verify that there are no remaining element quality issues.